Good morning, my friends. It is so cool to be back. I say back as if I've been anywhere. It's been a whole week. Sometimes that feels like so long in between live streams, and sometimes it feels like it was yesterday. So, just quickly before I get into the main topics of conversation for today, my regular Aboriginal awareness message for today is a shout out to Art Arc. They are an organisation that enables ethical purchase of Aboriginal art, because there is quite a problem in Australia of appropriation of Aboriginal art styles and exploitation of artists. So I'm chucking a link there in the chat. So, Station 240, COVID lockdown 2.0 sucks. Yes. So, today, if I was being UAV Futures, it would be today, but I'm not that energetic. It's just me at my normal level of energy. And something that I've noticed in relation to Station 240's comment is that I've seen so many people over the last week talk about problems that they are having emotionally with this isolation that we're experiencing here in Melbourne, at least, because we've gone through the first, well, at the moment we're calling it lockdown 2.0. This is the second wave that we're experiencing at the moment, and I think there is a lot of people are tired of it, and so they are starting to do things on the basis of emotion rather than logic. And unexpected energy levels are not at 0%. No. There's this general feeling that people don't want to do it the second time, which is always going to be an issue. So, and I'm seeing that a lot of people are having more problems with emotional imbalance and feeling like there is not a lot of point to things, not seeing a way out of our current situation. I don't want to talk about that too much right now. I could end up talking about that sort of thing a lot. The point of this live stream is to talk about more fun things and be a bit of a diversion from what's going on around us. And since we're pretty much all stuck at home at the moment, wherever we are in the world, it can be an opportunity to work on projects and build things and do fun things and try to use that as a positive escape from the little worlds that we're currently locked in. Sometimes it seems like the world has gone from a very large place to being just the walls of whatever room you're in, which can be really difficult. So I think the final thing I want to say about that is that if you are having issues with mental health, or just with the way you're feeling about the current situation, please don't keep it to yourself. If you can, talk to someone you trust about it, seek professional help if you need it. There are so many people that are going through this right now, and we don't want anything bad to happen. So make sure you seek help, please. All right. Yeah. Well, Scott, sorry, I've missed a whole lot of the comments, but Scott, I just saw it said, I'm ignoring the supposed relaxing of the rules, considering the lockdowns to be continuous, that way carrying on as I already have been. Yeah, I think that's the sensible thing to do. And Johnny said, I have had exactly 0% energy to do projects, even though I live in Sweden where we had a soft shutdown. So, yes, it can have really interesting side effects. I said that was the last thing I was going to say about this subject. But people react differently to these sorts of situations, and for some people, it's an opportunity to put other things aside, and there is the feeling that you can't do anything else anyway, so I might as well do the things that I want to do. But it can also totally kill your motivation. It can make you see something sitting on your workbench, a project that you love and you want to get into, and you just can't engage your brain. It's really frustrating, and you can have zero motivation and energy to follow through on that. So, well, maybe just having a couple of hours to chat about things today might help. Oh yes, and Chris said, take a nature walk if you're able, it heals. There are so many different things that you can do that will help. Some things that would help, but we can't in the current circumstances. So, I'm going to get on to some more positive things, talking about some tech stuff. Well, actually, no. In relation to tech stuff, I've got one more thing to talk about, and it's not quite tech, but I find it kind of interesting. And there are a few things that have brought this topic up. Oh, and it looks like there might be some tearing on the video at the moment in OBS. That is because I started Eagle and Fusion a little bit before this live stream, because I wanted to show you a couple of things, and unfortunately it's using up all the RAM on my computer, and so I get some tearing, but we will get to that. So the quick squirrel topic that I wanted to chase just for a moment is the Postal Service. The Postal Service has been something that I was hoping that the Postal Service is what would save us during this period. This is a period where we need to stay apart, so we need to be able to use online shopping. Any logistics company should be making a killing through this period, in theory, because demand will be way up, and there are so many packages being shipped that logistics organizations, either postal services or private companies, just can't keep up with it. And that's partly because of Johnny 50 sec. I don't think that'll get much, but thank you. So a couple of things this week in fact 3 things this week that really drove home to me how broken the system is right now. One is that on Friday I had an order, a Superhouse order that I took. I actually had a few orders, but one in particular I took to the post office, and I'd already obtained customs pre-clearance on it. So I'd gone through the Australia Post system, I'd lodged the details of the package, I got the customs clearance, I'd been issued the barcode, everything was ready to go. So I just took it down to the post office, and they scanned it, and on the computer it came up with a message, like it was an error message on the connection, saying connection refused. And that is because the Australia Post computer had tried to query the Romanian Postal Service's API, and the connection had been rejected, which meant that Australia Post could not lodge any packages going to Romania, like at all. It's just cut off from the world. They'd simply disabled the API that is used by external postal services to lodge packages. And I came back and got on Discord and expressed my frustration at it. And a Discord member, Lusu, who is in Romania, I think, checked and said that all flights into Romania had been cancelled. So there were no incoming aircraft, which meant nothing to carry packages. So I know I've ranted about this before, but 2 other things. One is, I'll get to the interesting thing second. The first thing is I finished off the routing on the Ether Uno prototype, the updated version. So it's got the ATmega 328 processor with the WISNet W5500 Ethernet interface, which is the same as on the official Ethernet Shield, for maximum compatibility with the Arduino IDE. I ordered those PCBs, they've been fabricated, they shipped, and somewhere around I have the tracking information. So they were finished, I think, on Friday, and then the PCBs were lodged with DHL for shipment. DHL picked them up on Saturday, and they then made it to the one of the Eastern distribution centers in China, and I got an update from customs with an estimated delivery date of August 26th. So right now they are in the air coming from China to Australia, and then it's going to be 10 days before they actually get to me, which seems like a bit of a crazy situation. And that part of the journey in normal times would be under 48 hours. Like in the past, I have ordered PCBs, had them fabricated, and then received them in my hands in, I think the fastest is about 4 days. And now it's taking 10 days just for the final leg of the journey on a premium DHL service, which costs a lot of money. It's not just using the postal service, and it's just because of this lack of capacity. So the final thing I want to say about the postal service, and this is more just because it's interesting, it's one of those things that when I first heard about this, my brain went, oh, what? Of course, like it seems so obvious in retrospect. And that is about the economics of it and the way the billing system works. I had a question during the week. Someone, I can't remember if it was on, I think it was on Twitter. Someone made a comment about the way cheap packages coming out of China are billed, and they were saying something like, how is it that Chinese sellers can send a package and give free shipping, or they might charge $1 for shipping or some tiny amount like that. Okay, so the answer is the way international treaties work in relation to postal services, like national postal services and international packages, combined with the way sliding scales work on shipping charges. Now, something I didn't realize, but I found out a little while ago, when the first national postal services were set up, the way the billing worked was the person receiving the letter or package paid the postage. So if you wanted to send something to someone, you would take it along to like USPS or whoever it is, Royal Mail, and post it, and then the person at the other end would be notified you have a letter and now you need to pay for it. So they would pay for receiving the letter. That puts the cost of using the system on the recipient, not on the sender. And so in our current situation, so obviously that isn't the way it's done now. What happens now is that the sender pays the postage, the receiver doesn't. But that means that in an e-commerce situation, the person who is selling the product has to charge the customer in order to cover the postage, because they have to pay it at the point where they send it. All right, that all sounds pretty obvious so far. Sender has a package, they pay for postage, it goes to the receiver doesn't pay anything at the point of pickup because they've already prepaid for the postage. Excuse me. So think about this. You have two countries. One country is manufacturing a whole lot of stuff and they're shipping a whole lot of orders to another country. The other country is receiving those orders and delivering them to customers. Both of those countries have to do work. 50% of the work has to be done in collecting the package and moving it and then shipping it overseas. The other 50% of the work is the receiver's country's postal service receiving the package and then delivering it to your door. So there is 50% done by one country's postal service, 50% of the work is done by the other country's postal service. But who paid for the postage? It's the country that sent it. They are the ones that get paid. The country that receives it has not been paid anything for the postage of actually delivering that package. So in a situation where you have a massive trade imbalance, for example, China and the US, or China and Australia, what happens is that all of the Chinese sellers are paying the Chinese postal service their fees for shipping the package, and the receiving country's postal service is not being paid for actually delivering the packages and doing all the work. So they're incurring expense and not being paid for it. So the result is that, and then there are international treaties that help balance this out. I'm not going to go into that too much, but there are rebates and different things that go on. But if you just look at it from that level, you can understand that all of the money is flowing into the system at the point where the goods are being shipped. It's not flowing into the system at the point where the goods are being delivered. So what that means is that countries like China that ship a lot of small packages have all of the money, and they can amortize the cost of providing the service across a very large number of packages. So they can charge a very small amount for it. And the other thing is that they have a very fine-grained increment. Here in Australia, for example, if I want to send a package, like say I've got something small like this, and I want to send it to a customer in the USA. There are a couple of different ways that can be sent. I can send it, if it's under 50 grams, and I can put it in a package that's less than 20 millimeters thick, so like a small padded envelope basically, with one circuit board in it, that prior to COVID times could have been sent as an international letter for $3.20. If that package goes just slightly over 50 grams, say I've got two circuit boards in there, all of a sudden it goes from $3.20 to $14.60 or whatever the next increment is, which is a 500 gram package. And then if you go above 500 grams, all of a sudden it's not $14 something, it's 20 something dollars, and it's a 2 kilo package. So it's got these very large discrete steps and very big increases in costs as you go up. The way the Postal Service works in China is not like that. They have very small increments, which means that the bottom end price, if you want to send something that's a few grams, costs you almost nothing. And the incremental cost of sending slightly bigger packages is very small increments. It's almost directly tied to the weight of whatever it is you're sending, which means that those factors combined mean it's incredibly economical for a Chinese vendor to send something overseas. So, that is not really a topic, a tech topic, but I thought it was interesting. I thought it was really cool. Like that little insight about where does the money go is a really interesting thing. All right, so let me do a little bit of catching up. Oh, okay. I have some back channel comments. Oh, Andy. Okay, Andy just messaged me in a little private back channel. Andy, yes please. If you could keep track of comments, that would be a really cool thing. Thank you. All right. So, let's see. Scott Miller said we need ICBMs, intercontinental ballistic mail missiles. Yeah, you know, the thing is that this situation right now, this is when we need drone deliveries, contactless. Like just have a drone drive or fly and drop a package at my doorstep and take a, record it all on video and that sort of thing. But the technology is not quite there. And so actually this is a subject that my friend Andy has talked about a couple of times, with the possibly misguided efforts to put so much work into building flying delivery drones, when to fly something takes a huge amount of energy in terms of like battery capacity, etc. Driving somewhere takes far less energy. So ground-based delivery systems. Okay, here's a look into the future a little bit. Just a hypothetical. Take a walking track, or like a bike path, or some kind of a track. Put a frame over it with an elevated track or walkway, and you could have wheeled drones moving very quickly over your head along these little tracks, And you could put solar panels on them, use them for power collection instead of stupid solar roadways. Let's not get into that. All right. Ooh. Andrew Gordon said, I watched a YouTube video recently about the huge spreadsheet that calculates international postage charges. I would like to see that. That sounds interesting. And Andrew Gordon said, my Get Wired stuff was picked up in Texas on Monday and was delivered to me in Christchurch, New Zealand on Friday with DHL. That's awesome. And that really illustrates how random this is. Well, it's not random, it's because of the lack of flights. But it's the lack of predictability that is a real problem at the moment. Okay. So, yeah, in the chat, Andy just said, build urban bike paths with roofs for weather protection and lighting for the evening, and the roof is the robot highway. Exactly. So we could have little delivery robots zipping along on the roofs above bike tracks and those sorts of things. And the energy required to drive something on wheels is so much less than the energy required to fly something through the air with propellers. Solar freaking roadways. Not roadways. The thing is that putting it on the road is a stupid idea. Putting it above a road is actually not such a stupid idea. Yeah. Yeah, and Austin's Creation said, why not trucks with robots? Truck goes to area, the robots go off and deliver to different streets, like the trucks from iRobot. Yeah, that's another model as well. And I know there are places that have been experimenting with that. So a truck that has smaller delivery robots that can leave from it. So it might travel from a distribution center and it could take a trip of like 10 kilometers to a certain area, and then the little delivery robots can go and do the final delivery, which might be a few hundred meters to different houses surrounding where the truck has gone. And Toby Robb said cars will self-drive, some will have package lockers. That is going to be really, really interesting. The idea... This is such a squirrel to chase. This is something that a few years ago I spent quite a lot of time reading up different predictions about the economic impacts of self-driving cars and secondary effects. One of the secondary effects, well, there are so many secondary effects. Things like decentralization of living and delivery services. Like the idea that the economics of taking a package and putting it in a self-driving car and say, take this to the other side of the city, of having a car that can do that compared to having a driver in the car that can do that is a big difference. A slightly off-topic question, but interesting. Antonio Victor said, what's your camera? Its content is very good. Right now, this camera is a Panasonic G85, and I'm running... So this is the camera that I use for recording my YouTube videos. It's sitting on a tripod, which is behind my monitor. So my monitor is just in front of the camera, and the camera is sort of peeking over the top looking at me. And then it's got HDMI out, which is going into a capture card, an HDMI capture device, which is plugged into my computer. So I'm capturing the HDMI output from the camera and then pulling that into OBS for streaming. All right. Yes, and Toby said, do you remember Tesla were trying to ride share your car while you're at work? Yeah. One of the changes to the economic models so that the idea that people could partly pay off their car by renting it back to the company they bought it from so that it can be used by other people when they're not using it. Oh, interesting. Station 240 said some big cities used to have underground mail systems. New York City had pneumatic mail. London had a mini freight subway between post offices. Oh, yes, so cool. The freight subway. I remember seeing some photos of that, and that is freaky. I've also seen some photos of unused subway stations on the London Underground, and that's some of the those are amazing. I just love. I don't know what it is. I think it might be because when I was young, I saw the original Planet of the Apes. I think it was. Is that the one with Charlton Heston? I can't remember. But I do remember in that at some point they ended up in an obviously abandoned subway, an old subway. So there was this station that was just overgrown and derelict. And the whole idea of things like abandoned subway stations and underground bunkers just fascinates me. I think that might be partly why I like games like Uncharted and The Last of Us, because it's exploring a sort of derelict world. Speaking of which, I have been replaying the original The Last of Us, and a bit more than halfway through at the moment. I've got to the point where it just switches over to where you're playing Ellie after Joel is impaled, falling off, spoiler alert, falling off the balcony. Because I played The Last of Us 2 when it first came out. I got that pretty much right away, played it through, so now I'm going back and playing The Last of Us, the original. And yeah, the games like that, what really gives me a buzz with those sorts of games is exploring hidden places, like finding your way into things, and yeah, I just like that. And I like abandoned. There's a YouTube channel called Abandoned Melbourne, I think it is, and they do urban exploration. So go into abandoned factories and old mansions that have been sitting derelict and show what's inside them, which is cool. All right. So Austin's Creation said, I read an article the other day where car manufacturers are having trouble making OTA, which is over the air, on their car because they use so many third-party chips with firmware they can't access. That is... yeah, okay. That certainly sounds plausible. I don't know the background to that story. I haven't read about it. So, OTA. All right. This is a squirrel we could chase. I did actually have a topic that I was going to talk about. Maybe we'll get back to that. I've got it in my notes here, so I won't forget it. Let's talk about OTA just for a second. This OTA, or over-the-air updates, are a mechanism for doing software updates on devices once they've already been deployed. And you would see this all the time. So I'm just giving the Cliff Notes background for those who haven't come across this idea. For example, you get a smart light globe, and you install it in your house, and it's been running for a while, and then there is a new feature that's released, or there is a bug that needs to be fixed. So there's an updated version of the firmware that needs to be installed on the light globe. How do you get your software updates out to your customers' devices that are spread all over the world, connected on random internet connections? You can't plug a USB cable into each of them and do updates. OTA, or over-the-air updates, are how you handle that. So the device itself typically will regularly connect back to something like an update server, and it will say, I am running version 2.31 of the firmware. Do you have anything newer for me? And it will respond no, or yes, I've got a newer version, here you go. The device then downloads the updated firmware, installs it on itself, reboots, and now you have the new firmware. So that can be either there are all sorts of nuances to how that works, but that's the general concept. So the idea is that as a manufacturer, what you can do is provide updates to the software that runs on your devices, and then you simply put it onto the update server, and you don't have to do anything else. All the devices take care of handling the updates themselves. So I've done a little bit of work on stuff related to this, not at any large scale, but a few years ago I did a project where I had a whole lot of OpenHAB boxes that were running Raspberry Pi, basically a Raspberry Pi with a custom board I designed in a box running OpenHAB on Raspbian, and they were installed at premises all around the place. So as part of that, I created an auto update system so that what I could do is create a new version of my management code that ran on those boxes, put it onto a web server, and then it would be pulled down and installed on those devices, so all the customers would get updates. There are so many ways you can screw that up. There are potential security problems. There are problems with updates failing and then having to roll back to whatever was the previously installed firmware. And there is the risk each time you do it that you're going to push out an update in a way that is going to either brick a whole bunch of customer devices, which is that's a nerve-wracking sort of experience when you push some kind of an update onto an update server, because what you might be doing is pushing out an update that causes some problem with those devices, which means that they either can't roll back to their previous version of their software, or the update fails in a way that it can never complete. And now you have a device that is in your customer's hands and it could be broken, non-functional, and you can't update it. So doing things like rolling out over-the-air updates is something that you have to be super careful about. And my general advice for that, it's like crypto. Don't roll your own. You really need to use a system that has been tried and vetted and has been through the tests of time and inspection. And if you can avoid writing your own system for managing over-the-air updates, you really should avoid it, because it can go badly wrong. And yeah. So Pancake Legend said, "I'm eternally impressed with how NASA manages to update and repair their probes and drones without bricking hundreds of millions of dollars worth of investment." Yes. So Pancake Legend is Andrew from Melbourne Hackerspace. Yes. I can just imagine the care that would have to go into pushing an update to a device that's in orbit. Oh, hang on, I don't have to imagine it. Yes, that's exactly what happened with ArduSat. I don't know if I want to chase that squirrel right now. I did a conference presentation many years ago. What was it called? It was basically about updating software on devices in orbit, and it was an overview of how the software update mechanism worked with ArduSat. Because the whole point of ArduSat, all right, the 30-second background once again. ArduSat was a family of satellites that were deployed into low Earth orbit with a number of sensors on them and a number of processors, and each processor could run an experiment using the available sensors on the satellite. And each satellite had 16 experiment nodes on it, so they could run 16 simultaneous experiments. Each of those was essentially an Arduino Uno. So it's like having an Arduino Uno on your bench with some sensors attached to it, and you can run your own sketch on it. Now the thing with that was the experiments that were running on the satellites could be updated live while the satellites were in orbit. The way that worked was that there was a management processor in the payload processor module, which was, what was the CPU? It was an ATmega 12, it wasn't a 2560, I think it was the 1280. It's like a cut down version of what's in the Arduino Mega. So it's still an 8-bit AVR, but it doesn't have all of the I/O of a 2560. I think it's got the same RAM and all of that sort of thing. I can't remember the details. This was years ago. So what happened was that the main flight controller or flight computer would receive a binary blob that was sent up by the uplink, and it would store it into memory in the satellite. And then the management node on the payload processor module would read that blob out of memory, and it would reset one of the experiment nodes and then send the binary blob into it. So the binary blob was just like a sketch, essentially, a compiled sketch. It's the end result of what happens if you're in the Arduino IDE and you hit upload. It's compiled on the computer into the binary that needs to be pushed across, the .hex file that needs to be pushed across to the board. In this case, it was doing it by compiling it here on Earth, sending the hex up to the satellite, and then from there it was being pushed into the specific node that was that needed to execute it. Nested squirrels, yes, we have achieved recursion almost. Yeah, so somewhere there is a video of me doing a conference talk about the process of pushing software updates onto the ArduSat satellites while they were in orbit. Bricking a satellite or something that's more remote than a satellite, that would just give me nightmares. Yeah, okay. Oh, right. Now, what have I missed? Yeah, some cool comments in relation to updates on space hardware. All right, so I think we're finished with that for now. The actual topic that I was going to talk a little bit about today, and this is where it'll be interesting to hear some feedback as well, what other people think about this, came out of a conversation with Daryl in the private supporter section of the Discord, actually just before the live stream. And Daryl had put in some comments, I just need to go back and find this now, about, which we're following on from last week's discussion. I was talking about, because last week I was talking about projects that were a challenge or particularly significant to me because they'd really helped me learn something new. And so one of the things Daryl said is, what's your view on what home automations are best to start with or implement? Obviously most people start with lights. And Daryl made the comment, in my view, I think understanding what you want to achieve and why is more important. That's more important than specific technical knowledge, like learning a particular thing about electronics or software or whatever it happens to be. And I totally agree with that, because if you don't have context, learning specific things is difficult. You can have someone sit down and explain to you, this is how a transistor works, or this is what this particular thing does. But you need an example to really put that in context to understand it. If you just look at it from the point of view of the pins on the part, it's not really going to make a whole lot of sense. But if you have a particular problem you're solving, like I have this microcontroller, and you might be thinking about it just at a block level, like I have this Wemos D1 Mini, and I have where is one? I don't have one here. And I have a relay, and I want to use these two things so that the D1 Mini can turn the relay on so that I can control something. Like that might be the basic problem that you're trying to solve. How do you link the two together? The solution, 99% of the time, is a transistor. So when you see the transistor in the context of taking the digital output from one device and then using it to switch another device and you see it being used as a digital switch or an amplifier or whatever the context happens to be, then it makes sense to you. And you really need those contexts or those problems to be things that matter to you a little, at least. Otherwise, you're just not going to be motivated to solve them. And so, yeah, so I think Daryl's comment is totally right, that understanding what you want to achieve and why is more important, that is, than specific technical knowledge. Okay, so to the point of what home automations are best to start with or implement. Obviously, most people start with lights. That was Daryl's comment. Okay. Lights are, lights are like the gateway drug. I don't think they used to be, because automating lights in the past was one of the more difficult things to do, and now it is one of the easier things to do with devices like LifeX smart globes. It becomes much less about electronics and dealing with the main side of things than replacing a single device and then linking it from a software point of view and achieving some form of control over it. So the fact that you can now walk into a hardware store and see Wi-Fi enabled light globes just sitting on the shelf, and you can buy one and take it home and plug it in and pull up the app on your phone and control it, that really, really low barrier to entry, I think, is something that gets people into home automation from the point of view of even being totally non-technical. Zero soldering required, zero coding required. It's install an app, plug in a device, and now you can control it. So, yeah, so I really think that is kind of like the current gateway drug to home automation, because once people start seeing that they can control things and do things like change the colors of lights if they're using something like LifeX, then as Scott said, John needs a set of giant devices to pick up when he starts this kind of discussion. Yeah, I need some big oversized props. Okay, so I think lighting gets people involved, but at its simplest level, you can do lighting with effectively zero technical knowledge by buying off-the-shelf things and loading an app on your phone. Now, that's not necessarily going to be the optimal experience, because it's not going to be nicely integrated with things like light switches. So if you turn off a light switch, then your smart lights all of a sudden aren't smart because they're just turned off. So, but it does get people into it. So I think the interesting thing in terms of learning more technically is when you go beyond that. And my personal opinion on that, if you want to go beyond the plugging in devices sort of stage, and you want to get into building your own things, I think the easiest thing to do, and possibly one of the more interesting things to do, is a little bit of sensing. Not necessarily even data logging, but the very first step is to grab my super oversized D1 Mini, get a board and a temperature sensor, plug them together, get some code running on it, and have it reporting some values. That little thing will it'll show you some basic concepts, and it's like the thin end of the wedge. So that will start getting you into doing things yourself rather than buying an off-the-shelf device and plugging it in. But it doesn't take a huge amount of knowledge. It's one of those easy wins where you'll probably need to download some example source code, compile it in the Arduino IDE if that's your thing, and plug in a couple of boards. You might have to do some soldering, but you might not. And you can get that real buzz of having put something together yourself and made it do something without having to jump over a whole lot of hurdles and learn a whole lot of electrical theory and physics and software development and all of those things. And I think that what that does is open up so many possibilities. If you build your own little, okay, let's use that as an example. You build your own small Wi-Fi enabled temperature sensor. And if you put on the right sort of device, then you'll also get humidity, you could get barometric pressure. You could get a couple of other interesting parameters as well. That little device, now yes, you can do the same thing off the shelf. You could go and buy a Xiaomi Akara environmental sensor, like a Zigbee device, put in a Zigbee controller, a Zigbee coordinator, and then you could start reporting values coming from your little Zigbee sensor. But doing it yourself is the thing that really opens up the world of possibilities. Because once you've done that, you can start thinking about more things that you can link into it. I really see it as being about tools or building blocks. There are a few different ways, different analogies. But imagine that you were building things out of wood, and there was one tool that you had. And what is it? What's going to be our first tool? Let's say a hammer. That means that you can take pieces of wood and nail them together because you've got a hammer. You can attach things, but you've got no way of cutting them to the size you want. So you're limited to building things that you can build with just a hammer. But then you learn how to use a saw, and now all of a sudden you can cut the timber to the size you want. And now that opens up a whole lot of extra possibilities for you. And then you learn how to use a chisel, and you learn how to use all the other tools that go along with it. And as you learn more of these tools, it opens up so many possibilities. And that is the same with this. You start with an off-the-shelf board like a D1 Mini, an off-the-shelf temperature sensor, the Arduino IDE, and those are the basics of the foundational building blocks. It's not enough to let you build all the things that your imagination is going to come up with, but that's equivalent to having the hammer and the saw. You can build the basics, you can make some things that are actually really interesting and useful and cool, and solve real problems for yourself. And then over time you start to learn about all of the other more advanced tools and different things that you can incorporate. And then before you know it, it's 10 years later and you've got a fully equipped workshop and you can build anything you like. Scott Miller said, I need an A4 size D1 Mini. This is a really good point from Andrew Gordon. My first home automation stuff was what I could do without spending much or any dollars. In my case, it was automating the settings on the heat pumps linked to the armed status of the alarm system. That is a really good point. Sorry, I'm just jumping back into a different topic here. All right. Financial motivation. This was a major thing for me as well. I said on a previous live stream that if I had been rich and I could early on, like when however old I was, I could have just said to an electrician, here's $100,000, install Clipsal C-Bus. I probably would have done it, and then I wouldn't have learnt anything. I would just have a system that would do most of what I wanted, not exactly what I wanted. It'd be within the limitations of the off-the-shelf system, but the basic problem would have been solved. But obviously I wasn't in a position to do that. And also we're talking about many years ago when it was normal to do monolithic home automation systems, not do the little point solutions like you can do these days. Buy one light globe and plug it in. The incremental cost now is very low. The upfront cost used to be very high. It would start with rewire your entire house. That would be like step one. So a lot of what I was doing early on was motivated by the fact that I liked the idea of things and I couldn't afford them. A good example of that actually is the the light switches that I've made. Now I know aesthetically they are not the same thing, but the original motivation for making my home automation light switches was that my wife and I saw the Postal Saturn switches, which are the ones with a rectangular piece of glass and little chrome buttons, and we saw them somewhere and thought, they look fantastic, we want something like that. But back in those days, a Postal Saturn switch, like just the light switch, I think was about $200 or $250 for one switch. And then for each switch you also needed the controller and everything else back in the switchboard. The actual cost per light switch of installing that sort of stuff was just crazy. And the idea of equipping a whole house with something like that was just inconceivable to us anyway. So I was largely motivated to make things because I wanted the result, but I couldn't afford to buy the commercial version. So I think that's an important part of it as well. And James made the comment, that's one thing I really like about OpenHab. I can code basically anything I want. A lot of other systems like Apple HomeKit become very, very difficult to do many complex automations. Yeah, so for people that are starting out with this sort of thing, I think one thing that you really need to keep in mind is the flexibility of the system that you're working with. Because so many systems, particularly things like CBus, which I've just been talking about, are very restricted in terms of what you can do to change the way they work. And things like OpenHab or Home Assistant, those are the two big ones. And so they're the ones I always talk about, but there are others as well. Let you get much more access to the internals and able to change things yourself. Now, this is something else that I've mentioned a couple of times in the past, and it directly ties into the whole thing I was talking about with getting started, which is a phenomenon called network effect, which I'm sure that many of you have already heard of. But the basic summary, and I'm probably going to butcher this, is that the value of a network of things is proportional to the number of relationships between the things in the network. And that grows, I think, exponentially. My maths isn't that strong. So if you've got two things, then there is one link between them. If you've got three things, then each of those things can relate to two other things. So you've got three links. And then if you've got four things, then each of those things relates to three other things. So you end up with a very complex mesh between them. Now the point of that is that the value of and the flexibility of a home automation system increases Metcalfe's law. So Andy just pointed out Metcalfe's law. So Metcalfe was the inventor of Ethernet. I haven't heard of Metcalfe's law, but I think that is that's basically the properly articulated version of what I'm trying to say very badly. What I found is, as I was starting to build my system, when I had a very small number of devices, they can only do a couple of things. But as you add more and more devices, it's like a door opening up, and it gives you more flexibility, and it's not linear. The potential of what you can do increases dramatically as you start to add more things. So if you have temperature sensors, that can give you some information. But if you have an HVAC system that you can control and you link it to the temperature sensors, all of a sudden you can build yourself a closed loop control system. And then if you have presence detection or a security system and you can monitor the alarm state, this comes back to, was it Scott? Someone said earlier, then you can say, I now have closed loop control over the HVAC system, and I have awareness of when there is somebody home, so I can change the set points depending on whether there's anyone home or not. And so what you can do is go from one thing, which is the temperature sensor, to two things, which is temperature sensor and HVAC control, and then three things, which is temperature sensor, HVAC control, and presence detection or occupancy detection. And as you add each of those things, the complexity of what you can do just increases dramatically. Yeah, so yes. All right. I'm starting to overheat here. What is going on? That's better. All right, and Scott pointed out, so this is following on from using something open like OpenHab or Home Assistant. Scott pointed out, add Node-RED to get fancy. And then there was another comment, which, Frank said, build a Tech 1B and do some machine coding. Hang on. I don't have a Tech 1B, but I have a Tech 1C. So this, whoops. So this is actually my first computer. So there's the Tech 1C, the Talking Electronics computer, and there's a Z80 processor up there, and memory chips over here. There's a ROM and a RAM chip, and there's the address counter, and then the data, and hexadecimal keypad for input. So convenient. This one's got the upgrade with the LCD on it. There's an output board that I designed. This is the classic example. One of the very first projects I ever did. So I was a teenager when I did this. There's a relay, a transistor to switch the relay, and controlled from this, which is like a little bus that I designed as well. And that was an input board, I think, so that was to detect inputs. Anyway, that has been sitting just inside the door of my lab for so long. Oh, yeah, Scott said real programmers use toggle switches on the front panel. I thought real programmers used the flapping wings of a butterfly to affect the electromagnetic field of the Earth to guide high energy particles to flip the bits within the memory directly. All right. Oh, Mike. Hey, Mike. Mike O'Connor said the sampling machines we build were controlled by a Z80 and then a Z180 for about 20 years, ending about 10 years ago. So Mike is a regular here and a regular at LinuxConf. I've mentioned his work a couple of times in the past, building very cool large-scale robots for handling things in shearing sheds, I think. I'll take $20 for things explained badly. I'm doing a terrible job of explaining things today. Yes, alright, so alrighty. Okay. NNM just said hi from Chicago. Now this is something else that I was going to bring up today. I am curious to see where people are from. So maybe give a wave from whatever city or country you happen to be in. Okay, see you, NN. But the reason I was wanting to bring this up is I've been thinking again about maybe changing the time of the live stream. Oh, Connecticut, Canada, London, Cairo, Milwaukee, Sydney. Yeah, there are lots of places. Thomasboro, Illinois, Perth, Cool. Victoria, BC. All these cool places. So, Andrew Cole says Richmond. Is that Richmond, Melbourne? Richmond, Hobart? Richmond, Virginia? So many Richmonds. So, Manitoba, Canada. Seaford. Barossa, South Australia. Lots of places. Cool. East Bentley. There's a Richmond in Sydney too. I'm sure there are Richmonds in just about every city in the world. Yeah, lots and lots of locations. So I know that Sion, Unexpected Maker, does a lot of very early live streams. So he gets up at some ridiculous hour and starts doing live streams Wednesday mornings. And if you are interested in ESP32 sort of stuff and the things he builds, you should go and check out Unexpected Maker, which is, you'll see his name linked in there. Marambina, hey John. But there is this perennial problem of what time of day do you live stream to be accessible to people around the world. So a subject that I raised just recently on Twitter, or no, it was in Discord, was maybe I should shift the time of this live stream. Now, I did this live stream pretty much to make it convenient for myself. 10 o'clock Sunday morning Melbourne time, so doing from 10 till 12, is a nice relaxed time for me because it means that I don't even need to set an alarm because there's no way I'm going to oversleep that sort of time. I can get up and then I've got a couple of hours to have a leisurely breakfast and get everything ready and then sit here and chat to all of you for a couple of hours, and then when I finish up, I go to lunch. So it's super convenient. But it's not necessarily convenient for viewers, and there are a couple of directions it could be pushed. I could start it earlier. So if I started at, say, 8 AM on Saturday, that time would be fine for me as well. I can do that. And that would mean that for people in Europe, it's not such a ridiculously late start. Like instead of starting at 1 AM, it would be starting at 11 PM. Something like that, depending on what country you're in. And for people in Australia, it would still mostly be okay. And for for people in the US, I think it would be good as well. The other possibility is to go late. Like I could start at, say, 8 PM on Sunday, which would make it Sunday morning, I think, in the US, and no, it would make it Sunday morning in Europe. Anyway, possible. So, yeah, 04:30 is a silly time to be awake. Yeah, Sion says I get up at 4:30 AM. I'm curious, Sion, is that because you would be doing that anyway, or are you specifically getting up at 4:30 AM just so that you can do live streams at ridiculously early times? So if it's already part of your normal sleep cycle and that's just the way you work, then that's totally understandable. Yeah. If you've got strong opinions on this, maybe pitch in. Let's just switch the entire world to UTC. Yes. With decimal time. Why go halfway? We need to abolish time zones and go for decimal time. So I want 10 hours per day, 100 minutes per hour, and 100 seconds per minute. That would be fantastic. Make things so much easier. Some people would say go for a binary time, which would make it much nicer for computers to keep track of. But for humans, I think 10 hours a day, 100 minutes an hour, 100 seconds a minute would be pretty good. So yeah, that would be a big improvement. A long time ago, I don't know if other people remember this, there was a company called Swatch and they tried to start a thing called internet time, and I think they called it beats instead of minutes. So it's like how many beats past the hour, and they were kind of, I think it was kind of related to this. I can't remember the details of how Swatch's weird alternate time system worked. Yeah. Yeah, Andy said the divisibility of 60 is awesome. Computers don't care about decimal. That is right. It's actually really interesting seeing really weird rounding issues coming out in things like spreadsheets. I've had this bite me before, and I've had it bite me in programming languages as well. It's one of those things that so many people just don't realize the difference between the internal storage of numbers in computers versus how they are represented to us as humans, and how if you take a number, like what might seem to us like a simple round number, it is very, very difficult to represent that in a computer, and you end up with weird rounding issues, and it'll give you a value that's 9.99999 when the actual number you're expecting to come out of the calculation was 10. Just odd stuff like that because of the way binary division and multiplication works. Aaron said, try to set up an atomic clock and tell what time it is. Well, on that subject, yes, I might get back to that in a little bit. Andrew said, the 6502 has a decimal flag for addition. It does BCD, which is binary coded decimal. Yeah. Dodgy says, round is your friend. Yeah, I use round a bit in coding. All right. I'm just talking about random stuff now. Time zones and number systems. On the subject of number systems. All right, here's a little squirrel that I'll chase just briefly. And I saw a comment that reminded me of this. I can remember so many years ago, how old would I have been? I don't know. I would have been a teenager, but for most people, they never question the base system of the numbers that we use. We are so accustomed to working in base 10 that our brains are almost hardwired into it. It's very hard to conceptualize different number systems unless you've had a lot of exposure to it. So growing up, like as a kid, obviously through primary school, I was taught to count, and you count with showing place value. So the first digit is the ones column, and then the second digit is the tens column. And then if you've got a number like 22, that means it's two tens and two, so it's a total of what we would call 22 items. And I remember my mind being blown when I read about, once I finally understood the difference between different bases and the difference between binary being base 2 and hexadecimal like base 16 and all of that sort of thing. And yeah, I don't know why I'm talking about this, but the point I'm making, I think, is that we are really accustomed to thinking about things in a certain way, and it can take a lot to overcome the inertia within our own brains, or the structures within our own brains, that makes us understand that there is another level below what our current level of understanding is. And by below, I mean the foundations on which our current understanding is built. So if you've spent your whole life thinking of numbers as being in base 10, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, etc., then you never really question the basis that exists on. Like, what is the fundamental principle at work? The fact that it is base 10, the fact that when you move along each digit in the number that's represented, it is an increment of 10 times the value over the previous column. And so, yeah, anyway, I just remember I must have been a young teenager, like 13 or something, reading a programming book. I might have been reading a book about computer system architecture and reading about binary and hexadecimal, because at the time I was reading a lot about Z80 sort of stuff. So, you know, there's the Tech 1C that you're sitting there where values are entered in hexadecimal. And when you initially are exposed to that sort of thing, you can tend to cargo cult it a little bit. And so you'll look at hexadecimal values. Well, I suppose it's a little bit like learning a foreign language. As you go through the stages of learning the language, mentally you are mapping what you are saying to a thought that's in your native language. You are not natively thinking in the other language. And so when you look at things like a hexadecimal number, or a binary number for that matter, what you do is look at the binary number and you think, oh, that is binary, 101. So that is, and then in your mind you are thinking of it as the decimal version of the number. You're always converting back to what is your native language, which is base 10 mathematics. And so you are converting and then doing whatever the thing is, whatever the operation is in base 10, and then possibly converting back again. And yeah, I just remember that moment when I was a young teen and thinking about how hexadecimal numbers work and octal numbers work and binary numbers work, and suddenly having this realization that you can think natively in those number systems. And yeah, anyway. So Aaron Haslaj made the comment that I watched a whole video about what flatness was and it broke my brain in the same way. That sounds really interesting. Flatness systems theory. So flatness in systems theory is a system property that extends the notion of controllability from linear systems to nonlinear dynamical systems. A system that has the flatness property is called a flat system. Flat systems have a fictitious flat output, which can be used to explicitly express all states and inputs in terms of the flat output and a finite number of its derivatives. Okay, that sounds like quite a mouthful of a definition, and it's a sort of thing that you could hear the words and it makes no sense in your brain. So I'm going to dig into that after this live stream, not right now, and see what that is all about, but it certainly sounds interesting. Yeah, and Joe said we're analog creatures. We have to tie concepts to reality in some way to make sense of them. Yeah. Oh, Aaron said, no, I meant physical flatness, but that is cool too. Okay. Physical flatness. Yeah, is that related to, oh, some call it fun. Oh, that is funny. All I know is that oct31 equals des 25. So octal 31 equals decimal 25. One date equals another. Okay, since we're chasing squirrels and we're talking about number systems, and flatness has been brought up, another thing that broke my brain and I thought was so cool, I just fell in love with this once I got it through my head, was hypercubes, and the whole idea of going beyond our 3 physical dimensions. Now, for those of you who haven't seen it, I'm going to see if I can find something to hypercube computer. I saw this article about a computer, and I think it was called a connection machine. All right, Here's a good representation of it. This is cool. Now, if you think about a representation of, if you were drawing something and you're drawing it on a piece of paper, you can only work in 2 dimensions because the paper is flat. And so you can draw a dot, which is a representation of a single dimensional object. So it's got no dimensions in X, Y, or Z. You can draw a line, which is a 2-dimensional, no, it's a 1-dimensional object. So it has length in one axis, but not in either of the other 2 axes. You can draw a square, which is a 2-dimensional object. Aha, here's the trick. How do you draw a cube on a piece of paper? Because what you're trying to do is represent a 3-dimensional object, but you are only allowed to work in 2 dimensions. So the thing is that if I asked you to draw a cube on a piece of paper, pretty much everybody would just do it. Like, you would draw a cube and you wouldn't really think that I'm asking you to do anything unusual. You would draw, I mean, I'm waving my hands in the air now. I'm going to show you some stuff on the screen in a second. You would draw a representation of a 3-dimensional object in 2 dimensions, and you would not think that it's unusual because we're so accustomed to representing that extra dimension. So by drawing the cube, you would have the square of the front of the cube, and then you would have the offset, sort of the back of the cube. You would see 2 sides of it, and then you'd see the edges that are joining it. I think pretty much everybody could draw a 3D cube on a 2D piece of paper. So what you have done by representing that is you have broken beyond the 2-dimensional limitation of the paper that you are using to represent the 3-dimensional concept. Okay, now this is the part that will break your brain. How do you draw a 4-dimensional cube on a piece of paper? And this is where things get really interesting. So, well, Aaron said paper is 3D though. Well, I'm thinking in terms of ideal paper. So it is flat, and what you're drawing on it is flat. So it's got no depth. It is technically flat. Station 240 said, meh, too early for maths. Okay. Now I'm going to, this is really cool, and this is computing related, so I'm going to show this. Where are we? Desktop. Okay, so hypercube, oh, I've got to get that out of the way. Hypercube internetwork topology. Once again, this is something that I think I was a teenager when I came across this. Really cheap paper, no thickness. Yeah, when I came across this, there was a computer called the Connection Machine. In fact, I'm going to see if I can find a picture of this, because it's so beautiful in the physical aesthetic of how it was designed. This is the Connection Machine. Can I find a... Yeah, so what you can see is that it's a cube, and then the cube is made up of 8 smaller cubes, and then inside this is a whole lot of cards. So I'm going to see if I can get to the bigger version of this image. Thinking Machines Corporation. Okay, come on. Hurry up, computer. Load, load, load. Somewhere in here. I want to get to the bigger version of that image. Where is it? Nope. Come on, Pinterest. Alright, let's just see if this will give us a big view. Not really. But what you can see there is a very funky looking computer. I have a feeling there might have even been one of these in Jurassic Park or one of those movies, just used as a prop because it looks like a really cool supercomputer. Alright, so the interesting thing about this is not the aesthetics, the fact that it looks like such a cool thing. It's the fact that it uses this hypercube internetwork topology to link all of the CPUs together. Because in this computer, there was some ridiculous number of CPUs. It was like, I can't remember, but maybe 1,024 CPUs or something. Which back in the day that this was built was just unheard of. This was in the days when a single, like, there were no multi-core processors outside of really specialist custom build systems like Cray supercomputers. You know, we're talking about the really out there technology, things that were beautifully handcrafted, and you couldn't just go and buy a multi-core CPU. There was no such thing. So having a computer that took a problem and broke it down into a whole lot of little component parts and then calculated them all at the same time and then gave you the result was pretty interesting. I was going to use the word revolutionary, but at the time, I think it was probably a bit too out there, and so we've really only started to see practical applications of this sort of system in modern supercomputers, which are, once again, consisting of a huge number of cores. But back then, this was just totally out there. Anyway, the point is that each of those CPUs, so if you want to build a computer and you want to put, say, 1,024 CPUs into it, how do you get them to communicate with each other? Now, there are a number of different bus topologies that you could use. The obvious thing is to put them all on a shared bus. So you have, say, a data bus, and it could be consisting of an address bus and a data bus. And when one of the CPUs wants to talk to its neighbor and say, I have this data that I've calculated, and I want to give it to you, and I want to get your data so that we can collaborate on this problem, you have to take control of the bus, and no other nodes can talk to each other while those two nodes are communicating. So you have bus contention. That is the simplest, the most naive, and the least efficient architecture that you could use. So what they did in the connection machine was come up with a very interesting architecture where every node, I can't remember how deep this went, like how many dimensions it went. What they do is connect every node to every other node through a hypercube architecture. Alright, say you take the example that I just used of a single communications bus. Is imagine you've got a row of CPUs. They're all on the same bus. It's like a line. So we've got this one-dimensional structure, and then when you want to communicate, messages pass along that line, and no other messages can pass along the line at the same time. Now imagine if you've got 4 CPUs and you arrange them in a square. That means that a CPU on this corner can communicate with the CPUs adjacent to it, but it can't communicate with the one that's diagonally across. But messages could be passed around. That's an improvement because it means that you can have communication happening between adjacent processors without blocking everybody else from communicating. And that is the basis of the concept. So what they did was they just started going into extra dimensions. So if you go, just like I was talking about before, you start with a point, you go to a line, then you go to a square, then you go to a representation of a cube. But what is beyond a cube? That is where all of this has been going. And this, I'll see if this comes up as a nice big diagram. It does. Ignore what is on the right for now, 3D to 4D. So this is the concept of what I was talking about. So we've got a point, which is a 0-dimensional representation. We've got a line, which is 1 dimensions. Then we can draw a square, which is 2 dimensions. And if I ask people to draw a box, this is probably approximately what they would draw. So it is a 2D representation of a 3D object. And if you think about it, each one of these steps is effectively a doubling of the stage before. So you start with a point, and then you go to 2 points, it gives you a line. And then from a line, you go to 4 points, which gives you a square. And then from the square, you go to 8 points, which gives you a cube. So with a cube architecture, you can, if you had one CPU at each of the joints on that square that you see, on that cube that you see there, that would be 8 CPUs joined on that little cube with communication between different nodes. And then this is the brain break part. If you look at the diagram to the right, where it says 3D to 4D, this is a representation of four-dimensional space. So as you go from 4 points is a square, 8 points is a cube, but what is 16 points? 16 points is what's called a hypercube. And you can think of it as being like two cubes offset and then with their vertices joined. And it looks really confusing. You could sit there and stare at this for a while and your brain really can't comprehend it. But just look at the red part there. In fact, I'll see if I can, I'll zoom in here. So ignore everything else and look at the red part, and you can see that it's a cube. It's a representation of a cube. Look at the black part, and you can see that it's a representation of a cube. If you just ignore all of the other colors, that is what you would draw if you draw a cube. So we have two cubes that are offset in the fourth dimension, and the offset is represented by those blue lines. So in this situation, what we have is a 2D representation of a four-dimensional object. Now, what I did when I first came across this whole concept, I think the key is that bit where you realize that when you are drawing a cube on a piece of paper, you are not drawing a cube. You're drawing a two-dimensional representation of a 3D object. Once you realize that you can do that you can represent more dimensions than are physically on the paper, it opens you up to the idea that you can represent more dimensions beyond that. So instead of drawing a three-dimensional object on the paper, we can now draw a four-dimensional object, and that's what you see on the right. And then beyond that, what happens next? You take that and you double it, and now you have a five-dimensional object. So you have a 5D hypercube. And I remember being at school. So when I figured this out, I became quite obsessed with it for a little while. And so I would sit in class when I was meant to be doing other things with a piece of paper and draw like 5D and 6D hypercubes. So you can just keep extrapolating this. You can go to, in theory, you can go to as many dimensions as you want, and it's a binary increase. So each increment doubles the number of nodes over the one before. Yeah, so I remember people at school thinking I was a little bit of a nutcase because I had a piece of paper and I would draw all these lines on it, and they would look at it and go, what? How does that work? And I'd say, it's a four-dimensional object, and then this one over here, this is a five-dimensional object. And yeah, it's a very hard thing to get your head around. Anyway, I never thought that this was a squirrel that I would be chasing today. Weird, weird, weird. But I am. Also, why are we talking about this? I don't know. Yeah. Andy just pointed out the fun thing about neural networks is effectively working in at least millions of dimensions. Head explodes. Yes. So neural networks are this is where I need to get Andy on. In fact, I remember when Andy explained this to me. We were sitting on a bus in China on our way. It was the trip, I think, from the airport. We had landed at Shenzhen Airport, and we were on a bus heading to... No, it was an airport outside of Shenzhen. We'd ended up going to a different airport for some reason. We were on a bus heading into the city, and Andy and I had a long conversation where he tried to explain to me some of the fundamentals of how neural networks operate. And I'm not even going to try, because I will butcher it so badly that I'll have him shouting at me in the comments saying, no, 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 that's not how it works. But in some ways it's actually tied to what I've just been talking about. It's about taking information and splitting it across a huge number of dimensions so that the relationships between the information can be seen in different ways. And I think I understood his explanation to some extent. And I think part of understanding the explanation of how neural networks work is having this whole thing in your head about being able to go into additional dimensions. And we're not talking about in a woo-woo sort of aliens extra dimensions way. I'm talking about in a mathematical way. So we can represent objects in dimensions that go way beyond the regular X, Y, Z 3 dimensions that we interact with on a day-to-day basis. And I'm also not talking about time. That's another thing entirely. I'm talking about representations of additional physical dimensions as a mathematical concept. Yeah, Mr. Fixit said, a sphere is a circle rotated about a single axis infinitely, or so I learned in calculus. Yes, which is... Scott said, oh yes, download the image and add the additional line that's driving some of us nuts. There is a missing line there. I wonder how many people can see it. Okay, so for those of you who can't see it, I'm going to zoom in here. Now, look at the red cube. Ignore everything else. We've got a single cube there. Look at the black cube. Ignore everything else. We've got a single black cube there. And so we've got two cubes that have been offset into the fourth dimension so that, well, okay, imagine you have two cubes that exist in the same physical space. So their corners are in the same place. They exactly match up. They're the same thing. And then you grab them and you drag them apart. What you're effectively doing there is making a hypercube that goes into the fourth dimension. And then each of the corners that were previously mapped, that were previously coincident, are linked together through that fourth dimension. And that's what those blue lines represent. So if this red cube was in the same place as the black cube, that corner would be in the same place as that corner. That corner would be in the same place as that corner. And then it gets dragged sideways and it stretches reality into the fourth dimension. But there is a corner that somehow mysteriously is not joined. It's this corner right here, which should be joined to that corner right there. So there should be another blue line that goes from there down to there. And it's missing. Someone overlooked it when they were making this diagram. Oh no, this is another brain twister. Dodgy Brothers Engineering said, I want to know who decided the red cube was forward of the black cube. It could just as easily have been behind it. Well, it could be behind. And there is no in front or behind. This is the thing. Those two cubes are not forward or behind in the 3 dimensions that we are thinking of. They are related to each other through the 4th dimension. which is not in front or behind or anything else. It's a totally different dimension that goes off in a different direction entirely. And then it's just that it's been decided to represent it in 2D by dragging one cube up and left effectively in the picture, if you take the red as being offset from the black. But it could have been dragged up and right, or in any direction in terms of representing it on the 2D page there. Okay, so Dodgy says part of the way it's drawn is the whole of the red line is seen in only part of the black. So what they've done is drawn the red, so the red goes over the top of the black. I think what would have been interesting is to alternate it, so have this black one go over the top of the red and have this one red go over the top of the black, etc. Just to break people's minds even more, because it is not in front or behind. They are not in front or behind each other. You are looking into the fourth dimension. So now take that whole structure, duplicate it and offset it again, and draw all of the links between the vertices, and now you have a 5D hypercube. Anyway, the point of all of this is this awesome looking computer used a multi-dimensional hypercube as its communication architecture between all the processor nodes. So what I can't remember the numbers, I'd have to look it up. It's probably on Wikipedia there somewhere. That's an interesting interpretation. It's a slightly different interpretation. Mr. Fixit said the fourth dimension is time. One cube is the second cube as it moves through time, so both cubes are in fact the same cube. That's an interesting way of looking at it. It's not quite the same though. In this case, what we're talking about is physical dimensions outside of time. And the reason that is important is the architecture of this hypercube. Where is it? That one? Yeah, this connection machine. So this was the breakthrough or the insight that the designers of the connection machine had, which is that if you have a whole lot of CPUs and you want them to talk to each other, and you want them to be able to do it efficiently without blocking communications between other unrelated CPUs that might be talking about their own thing, what you can do is create a multi-dimensional hypercube transport architecture that puts each processor on a node of the hypercube. And that then effectively gives you multiple pathways to communicate between physically distant nodes, because you can travel through those extra dimensions, which are actually just bits of wire in this case, in order to communicate. I really don't want to be chasing this squirrel, but an idea I just had is how interesting it would be to build a really tiny scale connection machine. Just build one that's maybe 4 dimensions. So what we could do is build a machine that uses microcontrollers, and it wouldn't really be any use for anything. It'll just be kind of an interesting experiment. Build a 4-dimensional hypercube physically using microcontrollers, and then link it up so that they can communicate with each other. And so the way this worked, I think, was that there were communications nodes. So if you've got a particular problem, say the sorts of problems that this type of computer are ideally suited to are things like climate modeling, or the relationships between things, like modeling airflow, where you've got particles that are interacting. I think part of the reason that it was developed in the first place was to do things like wind tunnel simulations, where the usual way of doing something like climate simulation is to have data points. So you've got a snapshot of the conditions across an area. You will have things like the temperature, the barometric pressure, and all of the other parameters. I don't know about this stuff, but let's just say pressure and, all right, let's say pressure. We'll keep this simple. Imagine, and we'll make it two-dimensional. Imagine we have a flat sheet, like a spreadsheet. Yeah, this is probably a fairly good way of doing it. Imagine you have a spreadsheet, and it is 10 by 10 grid. And in each cell, you have a number for pressure, like air pressure at that location. Now, what is going to happen is if you have high pressure in this location and low pressure in this location, it's going to want to try to equalize. So air from the high pressure will flow towards the low pressure, and over time those two pressures will balance out. So what you can do is, if you've got a grid, which is a static representation of pressure, and it's a 10 by 10 matrix, you can have a computer that goes through and looks at the first cell and then looks at the cells around it and then figures out, is this value higher or lower? And if it's lower, then there is going to be wind going in the direction towards the lower pressure cell, and then the value that is after some period of time is going to be that one will go up, one will go down, they'll become closer to each other. And then you move on to the next cell, you look at all its neighbors and you do the calculations, you move on to the next cell, you do the calculations. So you have to, your computer doing one cell at a time has to go over this grid and do 100 sets of comparisons. So it's going to complete the task in the time it takes to do 100 sequential sets of comparisons. Now, the brilliance of something like the connection machine or a hypercube computer or any of the supercomputers that are used for things like climate modeling today is that instead of having one CPU or one process that looks at the first cell, then looks at the second cell, then looks at the third cell, what you do is you load the value of each of them into a totally separate CPU and you calculate them all at the same time. And then you get the result back in one cycle instead of 100 cycles. And the other interesting thing is that the computers that are calculating the adjacent cells can talk to each other. And this is where the hypercube architecture comes in. So you can have a processor or a computer that is responsible for one particular cell in your matrix, and it communicates with all of the computers that are associated with the cells around it and says, hey, I've got this value, what value have you got? They share the information between them and they come out with a result. So you can then get the result of, after n period of time has elapsed, where is the wind going to be in this system, how is the pressure going to change, and all of the other things, and you then get an output, so you can get a result very, very fast. Now, if you have a large weather system, now there are many more parameters. Obviously, if you have a system where you've got different air pressures across a matrix, and there is no other factor, entropy will set in, and you will have it all equalize over time. So you'll get wind moving around within the system as the air pressure equalizes, and after a certain period of time you will have uniform pressure across the entire system. But of course the Earth is much more complicated than that. We have heating due to the sun and the rotation of the Earth, so the heating moves. So weather prediction has to factor in a whole lot of extra things. It's not just a matter of equalizing the values of cells, but that represents the concept. And that's really where things like the connection machine and the supercomputers that are used for weather prediction today are so powerful, because instead of having to crunch over each little section of the problem, you split the problem across 1,000 processes, or however many. So what you do is you take the problem and you chunk it according to the size of the computer that you have. And if you have lots and lots of processes, you can chunk it into lots and lots of little bits, and then you can process them all at the same time and get a result. So anyway, way beyond my pay grade. I just think it's really cool. I love looking at this sort of stuff. So I've just been ranting and ignoring the chat. What have I missed? James just said if I had a green screen I could be doing a weather report right now. Yes, and we have a high pressure system over here with Yes. Oh, right. Dodgy said, I've taken the explanation to the next dimension with the arm waving. Yeah. uh, oh, right. Here. Minecraft on... Ooh. Gerald42 said, Minecraft on a hypercube has always seemed like an interesting idea. Yeah. Yes. Let's see. Is there anything else that I wanted to cover today? These are not the squirrels I was expecting to chase. What else do I have? Oh, okay. Just a... Alright. A couple of quickie things. Last live stream, I promised that I would not start about... sorry, I'm going to try to ignore the chat for now, or I'm going to start chasing squirrels again. I promised that I would not start a new project until I had the ESP flasher ready to ship. I did it. I started a new project. Although, okay, there are mitigating circumstances. One is, that's the ESP flasher in a bag with a hang tag on it, you know, ready to ship. And I've got a few of them. So ESP flashes are just about ready to go. And to the extent that they are now packaged and I could actually send them to people. So I owe a couple to Aaron, and I also, not in reach, but over on the shelf, I've got some flasher adapters that give alternative pinouts for it. And so, yeah, the good news is that this is going to be going live on my site. I still need to do a video about it. Last night I did some updates on the graphics that show the pinout, and I've changed the name once again. I've tried so hard to come up with some kind of a name for the programming header on an ESP board that would not have a name conflict with something else, like I don't know, ESP prog. Those are both used. There are lots of different variations. So I've kind of settled on just calling the header format ESP flash, and hopefully that's unique enough. So this board is the ESP flasher board, which is a USB interface with the header that lets you then program the program your target device. But the header format, as in the pins that I use on the target device, from now on I'm going to call it ESP flash. So that's going to be the header. Alright. So James, thank you for the super chat. This is for an A-sized version of the sun for the next time Superhouse TV does his hand wavy thing. What do you mean an A4 sized version of the sun? I don't get the sun reference. Alright. Alright, so this will be ready, available very soon. And two other things, because I've almost used up my 2 hours. Oh, weather presenter, okay. Yes, James broke me. Oh, what? Aaron, thank you very much. Sorry for the squirrels. What are you talking about? We love squirrels. Squirrels are the best. I like chasing squirrels. That's where all the interesting things come up. But thank you very much for that contribution. I really appreciate it. So, the two final things, hopefully. The the extra project that I chased onto, which is why I've got Eagle and Fusion open, is ages ago, like months and months ago, I ordered some parts and forgot about them. And then they arrived. Because the shipping situation is so broken at the moment, this is when I was working on the Zigbee to Tasmoda device. So this, let's see, can I get this in view of the camera? Just. This is going to be this is going to be shown on a video as well soon. So internally, this is a Wemos D1 Mini with a CC2531 module on it. I'm just getting some blue tack off the side here, and a little power amplifier so that it's got good range, and it's also got good sensitivity with this antenna on it. And that's a Zigbee coordinator running Zigbee to MQ. What am I saying? Tasmoda to. I can't get it right. Zigbee to Tasmoda is the firmware that's running on this. And I think that's actually been rolled into the main Tasmoda code now. So this is the Zigbee coordinator for my network. It's receiving data from sensors all around the place and connecting to Wi-Fi, and then it pushes messages out to my MQTT broker. So that's how I'm getting data from all my Zigbee Akara sensors and door switches and all those sorts of things. Anyway, when I did this, I also ordered some little surface mount modules, and then because that was around the period that all of the isolation started and everybody's postal services started falling over, I'm just going to shove that back up where it normally lives, blue tacked up on the thing. I forgot about it, and then a package arrived with these. These are surface mount Zigbee modules, and the advantage of these is that it means that I can have a very small low profile device. So if I switch back to the desktop view, this is a super quick little thing that I did just while sitting in front of the couch watching TV. So it is a little shield for a Wemos D1 Mini. It's got the headers on here, and then it's got the surface mount module. So that mod 1 that you can see there, the E18 MS1PA, is what's in this tape, each one of those modules. And if we go to the board view, so it's a shield for a Wemos D1 Mini. Now you can see that there is a cutout just here. That is because I want to make this as low profile as possible. So my goal with this was just to make a super tiny Zigbee node, which could be either a coordinator or it could be a sensor or an actuator or something. And so Peter asked, how is that different to Zigbee to MQTT? It's very similar. I have a feeling that the Zigbee to MQTT code ended up being rolled into the Tasmoda to MQTT. No, the Zigbee to Tasmoda code. I can't remember the code lineage there, but what it allows you to do is install Tasmoda onto a device with a Zigbee interface on it, and then act as a bridge. So it can be a coordinator and link your Zigbee network to MQTT bidirectionally, which is really cool. So what we have on the screen there is the shield, and you can see there's the cutout, which is where the USB part goes. And if we switch to, so the reason for that cutout, maybe if I switch to Fusion 360 it'll make a little bit more sense. So this is the design, the shield with the surface mount module on it. There are no headers represented in this model, but you can see that there is the cutout here for the USB socket. Now the reason for that is, if I switch back to front view, don't know how good the focus is going to be on this, but we'll see. You can see there is the USB socket sticking up on the top of the board. It's the highest thing on the board. There are a couple of other parts as well, but this is the highest. Now, if I get a header, if I just grab a pin header, let's see, I've got one that's already the right length. Yeah, here are a couple. The idea being, I want to make this super low profile and solder these two PCBs together without using a socket. So instead of putting like header sockets on here and then pins on the shield and plugging it in, which means you end up with a thing that's like this thick, my plan is to put pin headers into the D1 Mini and then put the other PCB directly onto the pin headers and just solder it all together. So we will end up with two PCBs that are separated by only 2.5 millimeters or whatever the plastic spacer is. And the highest thing on there is the USB socket. And so what will happen is that if we switch back to the desktop view, that slot that you can see here will allow this to fit really tightly over the USB socket. And the end result is that we'll be able to make a Zigbee coordinator or a Zigbee node that is essentially the size of a D1 Mini, not much bigger. It's a D1 Mini with another PCB sandwiched onto it very tightly. Not much space between them at all. Now, it's certainly not going to have the performance of the other thing that I've made because that's got a separate antenna, whereas these surface mount modules have PCB strip antennas. Will there be clearance for the USB cable? Yes, there is. So the end of the D1 Mini, I could pull a D1 Mini into this model as well. In fact, I wonder if I have a D1 Mini. Let's see. Let's go for an explore. Where would I have a D1 Mini? Maybe I'll do a search. D1 Mini. I think I might have a D1 Mini somewhere in my D1 Zig? No, I don't have a D1 Mini in my library, which is kind of strange. I should have one. Yeah, anyway, so what will happen is that the D1 Mini will go underneath this, the USB socket will fit up into this cavity, and then the USB cable will plug in at this end. So not ideal from an antenna point of view or anything else, but I figure that this is just meant to be like it's just me playing around basically. I've got these, I wanted to make something, and I did a quick and easy thing while I was watching TV one night. So that was me breaking my promise that I wouldn't do another board until I'd already finished the ESP flasher. But the flasher is technically finished, it's just not available yet, and I haven't done the video about it yet. So the other thing is that last weekend I got a Synology disk station. So I got a DS, what is it, an 1819 Plus. Station 240 says, I think he has enough bait, he needs squirrel repellent. Yeah, lots of squirrel chasing. One of the big problems I've been having recently is storage and managing all of the files in relation to video production in particular. I've run out of I just ended up with a big mess. So I had, how many? I think I had 7 hard disks in my Ubuntu machine, and I had the internal drive obviously in my iMac plus 3 external USB disks ranging from 2 terabytes to 8 terabytes each. And the problem is that everything was fragmented. Like I had one drive for source files for video projects, I had another one for Final Cut Pro libraries, I had another one for output files, so once I did the render of the video it got stored onto another disk, and then there was a backup disk which I was arsyncing some stuff around. It all ended up being a bit of a pain, and it was like this big kludgy mess. So something that I experimented with a little bit was making my own NAS. There are quite a few different options. If you want to build a NAS yourself and you've got spare PC hardware, you can install a number of different things. Like there's FreeNAS and lots of options. But it got to the point where I just wanted something that was going to work and I didn't have to think about it too much. So I ended up forking out and bought a Synology DS1819 Plus, which is an 8-bay NAS. Oh, sorry, I've been saying NAS. Network attached storage is what it is. And I wonder if you can see it. You can almost see it. It's currently sitting on the bench because I've been moving stuff around. Where's the camera? I'll switch back to here. It's out of focus, but that black box right there, that's the edge of it. So that is an 8-bay storage server, which I've now set up. So what I've done is migrated a whole bunch of disks into it and started copying some things over. So I've got 8 disks and I've split it up into a couple of different storage pools. So the first 5 disks, so disks 1 through 5, are on one storage pool, and then disks 6, 7 and 8, which are the little ones, they're only 2 terabytes each, they're on a second storage pool which I'm using for Time Machine. So a fair bit of this week has been copying files around, and it takes an amazingly long time when you've got to move many terabytes of data over the network. It just takes time. And also rebuilding the storage array. As I've been messing around with it, because I didn't have enough, I couldn't just buy new disks. What I had to do was take one disk, I took a couple of disks, set them up in the NAS, and then copied some content over, which freed up a disk. And then I took that disk and put it into the NAS and then rebuilt the array, which increased the space, and then I could copy it off another disk. And then each time I rebuilt the array, it would take like 24 hours to do its resync across all the disks. So this entire week has been spent copying and moving disks, in between doing other things, of course. But the result now is that I've got 2 storage pools, one of which I'm using for video projects, and the other one which I'm using for Time Machine backups. And that is going to be a huge help. Sorry, I was just showing stuff there and it wasn't even on screen. It is there. So this is the NAS. I've got so these are the 8 disks that are currently in it, and then divided into 2 storage pools. One storage pool for video storage, one for Time Machine, and then they've got shares on the network. So the next thing beyond this is backing up the NAS, because it's no good to have all of your eggs in one basket and then drop the basket. Yeah. Alrighty. Yes. And I think that was the last thing I was going to cover today. Oh yeah, so Mr. Fixit just said, this week I lost two terabyte drives just as I was about to move them to new drives. I'm going to RAID drives next. Yep. Yeah. So, a couple of final comments that I'll just respond to, and then I'm going to have to sign off. So, Dodgy asked the question about clearance for the USB cable. Yes, there will be. And Adam P said, I wonder how much the USB connector will interact with the antenna. That was exactly what I was wondering about, because what's going to happen is on this board, this cavity right here is where the USB socket is going to be. And you can see the PCB trace antenna is on the top, and the USB socket is metal and it's grounded. So the USB socket here is going to fit straight into that cavity and be directly below the antenna. Now this is where I would really like something like a spectrum analyzer, where I could do some field strength measurements and see the effects of things, because it would be quite cool to have the shield separated by some distance, like put standoffs or something on there, or even jumper wires, and measure the field strength, and then do it so that it's joined directly on, and have the USB socket really close to the antenna, and see if it makes a difference. Unfortunately, I don't have a spectrum analyzer, so I don't really have a way of measuring the effect of that sort of thing, but oh well. This is just a playing around fun thing, and I'll see how well it works in practice. Other question? Oh, and Peter said, can you show the one you made one day in detail? I think that's in relation to the other version of the Zigbee to Tasmota thing. Zigbee to Tasmota. I don't know why. I just can't grasp the thing in my brain, because there is Zigbee to MQTT. There is, anyway, different combinations. I get the words in the wrong order. Yes, I'm going to show that. And Mike says, I have 10 boards who need the ESP flasher. Cool. I have the ESP flasher. I just need to finish all of the things that go along with actually making it available. But, Mike, I will send you an ESP flasher. I certainly owe you more than that after all the things you've done over the years with helping out for the Open Hardware Miniconf. So I will, I'll get some shipping details and send that to you. Alright. I am going to sign off. You could at least measure RSSI from Tasmota. Yeah, that's true. So James pointed out RSSI is received signal strength indicator. What I could do is have two of these, one with the shield separated and one with it joined, and have them, nearby each other, and get the signal strength reading from the two of them when they're connected to some other device. That could be interesting. Alright, so there are ways to check that. Cool. Alright. Thank you for coming and hanging out with me on a Sunday morning. During this week, I've been feeling a bit blur as well about the state of the world, and being able to come and talk about these sorts of things and have my brain just go off in random directions is really interesting. For me anyway, and hopefully for you as well. I didn't think I was going to be talking about the connection machine when I sat down here this morning, but I love talking about stuff like that. And in normal day-to-day course of events, there is nobody I can talk to about things like multi-dimensional hypercubes. I mean, there are. I've got friends I can talk to about that sort of thing, but a lot of the time it just doesn't come up. The opportunity to talk about those things just doesn't happen. So going off on those random tangents and chasing squirrels on a Sunday morning is something that I find really interesting. And thank you for suffering through it with me. So have a great Sunday afternoon if you're here in Melbourne, or whatever day it is, wherever you are. Please go along and check out the Discord if you want to talk about things. I'm still not sure what I'll do about the timing of future live streams. For now, it's going to stick at 10. Oh, one thing I should mention. I'm going to have a guest coming up very soon on the very interesting subject of energy monitoring for home automation systems. It's someone who has done a lot of work, and I'm not going to mention who it is just yet. If you've been following on Twitter, you might have seen a conversation which has led to it, and you've probably figured it out. But coming up very soon on a live stream, I'm going to have a special guest who will talk about his energy monitoring projects and all of the stuff he's done in relation to it. That will be really cool. I'm looking forward to that. So I will announce that one in plenty of advance time. Normally what I do is post live streams like the night before, which doesn't give people much time to think about it in advance. But when I have a guest arranged in advance, I want to give at least a few days notice so that you can have time to think about the subject and what's going to be discussed, and then maybe ask some specific questions. So I'm going to sign off and go and grab some lunch and a drink for my now sore throat. Have a great weekend, and I will see you next. How do I get out of this thing? I've got to find the end screen. I need to make one of those little smart button things. Alright, that's it. We're out of here. Bye.